So let's start by solving some problems. It says the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. A says find the probability that a randomly selected student scored more than 65 on the exam. So let's write down what we know. We write down, no, our mean is 63 and our standard deviation is 5. We know that our random variable is going to equal a score on a final exam. If we were writing out this, we know that some random variable has a normal distribution and we could write it this way. What we are trying to find is the probability x is greater than 65, more than, greater than, same thing. So if we were to sketch this out, we know that our mean is 63, and we're just going to guess where this might be, but this is what we are trying to find right there. Turn your calculator on, I'll clear it out. Second, distribution. The previous video I talked about how we are not going to use this normal PDF. We'll be using the normal CDF and the inverse norm. So for this one, we are going to use the normal CDF. We'll select that. And then what we're going to do is we are going to enter in our values. So the normal CDF, this first value is our lower value. 65 is the lowest score we're trying to find. This 1E99 is our upper. And let me explain that. If you look at this note here, we get this. You can also write 10 raised to the 99. It's the same thing. And you can get it. The E, we use the EE key. So there's the EE key. We hit second and then EE and 99, and that's how you put it in your calculator. Okay, or you can use this. So the number 10 to the 99 or E to the 99 is way out in the right tail, all right? This calculates all these way out here. And then if we wanted to go in the other direction and calculate all these way out to the left, we would use this, negative 1e to the 99, negative 10 to the 99. So for this one, since we are going all the way out to the right, we are using 1e to the 99, or you can just put e to the 99. This is our mu, our mean, and this is our standard deviation, our sigma. So let's just plug this in exactly as we have here. We want to find 65 or greater, and our mean is 63. You separate them with commas, and here we get this, which is a probability, so it's a percent. So our answer is 34.46%. Okay, so there's a probability of 34.46% that a student scored more than 65 on the exam. So now let's continue on with some more problems. B says find the probability that a randomly selected student scored less than 85. So here we are finding probability less than 85. This is what we are looking for. So we are going to do normal CDF. Our first one is our lower limit. So initially, you might look up at this note and say, okay, because I'm trying to find this way out here, it's less than 85. So let me quick draw what this might look like. There's my 63. Say this is 85. We're trying to find all of this. What's the probability that some randomly selected student scored less than 85? But when you think about this, I want you to take a moment and think about the logic of this. We are talking about a final exam. You can't have a score on a final exam of negative numbers. So instead, because we thought about this problem and we're going to use some logic here, 0 is going to be our lower value. Our highest value is 85. Our mean is 63. Our standard deviation is 5. So we're going to go back in here, 0, 85, 63, 5. I get a value, 0.9999, which is approximately 100%. So this tells us that pretty much 100%, we are going to say 100% of the students scored less than 85 on their final exam. C says find the 90th percentile. That is, find the score K that has 90% of the scores below K and 10% of the scores above K. Don't let this jargon mess you up. All we are trying to do is find the 90th percentile, and the way that we do it, if we look up, back up here at the calculator notes, we are going to use the inverse norm because it finds percentiles. So we have to do the percent as a decimal, mean, standard deviation. So here we have inverse norm, 0.90, 63, and 5. We get 69.41. So what this means is that 90% of the scores fall below 69.41 on the exam. Find the 70th percentile. Here we do the same thing, 0.70, 63, 5. So we're going to plug this in. Now, I don't know if you know this trick or not, but on our calculators, so I just did inverse norm, and if I want to just quickly pull up the inverse norm again, pull up the last entry, you can hit second and entry. It will pull up exactly what I just put in, and because I'm only changing one thing, it makes it easy to just make that change, not have to enter everything in all over again. So here I got an answer of 65.62. And what this means is that 70% of the scores are below 65.62.